Welcome into this video, and I'm going to talk about the interconversion between states of matter. Now, the first thing I'm going to do an analysis of the conversion between solid as a state of matter, liquid, and gas. And I'm going to have my first sketch, which is a solid. I'm going to have my solid. I'm going to have my liquid. And lastly, I'm going to have my gas. And I want us to be very creative here. I can have a situation whereby a liquid, sorry, not really a liquid. I can have a situation whereby a solid changes to a liquid, a liquid changes to a gas. Can also have a situation whereby a gas changes to a liquid, and a liquid changes to solid. So I can also have a situation whereby my own, I want to use a different color for us to see whatever thing that is going on. Can have a situation whereby solid changes directly to a gas, and the gas can also change directly to solid. So I'm going to label this as A. This is going to be my B. This is C. This is D. This is E. And this is F. Now, what I want you to understand is, in a situation whereby we are dealing with interconversion of states, we are majorly talking about how or under what conditions does a solid changes to a liquid, and a liquid changes to gas, and vice versa. Now, as a student, you really need to know these steps because they are forming the basis and the basics of chemistry. And I always expect you to know them. Now, I'm going to start my analysis process A. I'm going to start with the process and conditions on which that process occurs. Now, A. Process A is called melting, solid to liquid, is melting. Conditions. For process A to occur, the first thing that must happen, heat energy must be available. Heat energy must be available, and that heat, enough heat must be absorbed. Third, the forces of attraction between the particles forming the solid must be overcome. Unless these forces of attraction are overcome, melting will not occur. Because we said that in the solid state, the particles are closely packed together based on the particulate, and also in the kinetic we said however much they have energy or they can absorb energy, their energy can only make them vibrate at fixed positions. But if excess energy is absorbed until the particles now have excess energy and the forces of attraction between the particles is overcome, the solid substance will change state and therefore will undergo melting to form liquid. The next one, is process B. Process B. And if we go back, B is liquid changing to gas. B is liquid changing to gas. So if it is a liquid changing to gas, we know for a liquid to change to gas, it must undergo boiling. So not heating, it is boiling. Boiling. What conditions? The first one is heat energy must be provided. That's why for us to boil water, we have to use a water heater, or we use a gas heater or electric heater, meaning heat energy must be provided. Secondly, remember in liquid state they have kinetic energy. Not that they don't have, they have kinetic energy. That's why the particles can move but within the liquid. So what we need to overcome here is the energy or the forces of attraction holding the liquid particles together. So the second thing is heat energy must be absorbed. Heat energy must be absorbed. Third, the forces of attraction holding the liquid particles together must be overcome. Must be overcome. Unless these forces are overcome, liquid will not change into gas. That's why whenever you're boiling water, you'll realize that when you start boiling, you'll see some fumes coming out, but you won't see bubbles. We always say that water has boiled when the whole system have broken loose and it is bubbling. But when you start heating, the reason as why it is not changing into gas immediately is because it is still absorbing the heat energy being supplied, and the heat energy is still breaking the forces of attraction between the particles holding the liquid particles together. Okay, so that's why liquids must be heated for a certain duration until a specific energy is provided when they change state now from liquid to gas. Now we are moving to the next. The next one is C. C is gas to liquid. Gas to liquid. The next one is gas to liquid. This is our C. Gas to liquid. Gas to liquid is condensation. Gas to liquid is condensation. And remember, we had heated it until we reached the third stage of the state of matter. So we want to bring that vapor back now to liquid. The first key thing you need to know is we don't need source of heat now. So heat energy is lost. We don't need it. Now, for a gas to turn back to a liquid, the forces of attraction holding the gas particles, remember, initially, and I want us to understand this very well. Initially, when we were forming gas from liquid, we broke the forces of attraction holding the liquid particles together. So when they were broken, the distance between the particles lengthened. That's when we formed a gas. Now, for us to form a liquid, that force of attraction that were forming the liquid particles is regained back. Regaining the forces of attraction that were broken in the liquid state. To form gas. So I can therefore conclude by saying that's what is happening. So I can simply say that I am strengthening the forces of attraction, strengthening and shortening the forces of attraction between the gases, strengthening, and shortening forces of attraction between gas particles. That's when condensation will occur. That's when condensation will occur. Next stage is D, And in D, we have liquid to solid. In D, we have liquid to solid. And when that is occurring, sorry, my battery is low. And when that is occurring, we really need to know that for liquid to change to solid, D, for liquid to change to solid, we need freezing. And for freezing to occur, heat energy is lost, and we still continue to strengthen and shorten forces of attraction between liquid particles. When that occurs, what will happen? A solid will be formed. And what will be the characteristics of that solid? It will have closely packed particles. It will have closely packed particles. So when we have closely packed particles, that's when we say we have managed to change liquid to solid. Next stage that I'm moving to is E. E and F, I'm going to put them together, though they are different processes. I'm going to explain that. Though they are different processes. Now E in E, let me go back and revisit it again so that E is gas changing to liquid, and F is gas changing to a solid, sorry, and F is solid changing to gas. Now, I want to talk about E and F at the same time. Most students always know about F. They always know about F, and they don't always find problem tackling F, because F is simply sublimation, and it is just changing from solid directly to gas without passing through liquid. And the reverse of sublimation is always deposition. And we have substances that always undergo this. And these substances, example is always dry ice. Dry ice is always one of them. The other one is naphthalene. The other one is camphor. There are still three more, which now I want you to write for me in the comment section. Yeah, as a good student who has been following this class, I want you to go and do research. Do your own research as a student. Look for the 3 more examples of substances which undergo sublimation and deposition at the same time. And I want you to write for me 3 more examples in the comment section below. Thank you. Have a wonderful time. Let us meet in the next video.